All right, so here is another little video to help you as you're preparing for your Unit 2 test. Don't forget the mole, very important in measuring chemicals. Once you know moles of a chemical, you can figure out the number of particles. So if it's an element, that would be atoms. If it's a covalent compound, that would be molecules. And don't forget what that number is called. Yes, hopefully you were thinking Avogadro's number. Exactly. And so we can use those moles to represent those quantities of chemicals. So when we're looking at a reaction, don't forget those coefficients are telling us the moles of the chemical. If there is no coefficient there, like in this case, there is an understood 1 right here. And so I can see that 2 moles of NO reacts with 1 mole of oxygen gas to produce 2 moles of NO2 gas. So important that you can do that. So let's try one really quick. Oh, but first let me remind you of these molar conversions. So once you know moles, you can figure out particles. You can figure out liters of a gas. And we will spend some time coming up this semester to study just gases. Don't forget 1 mole also equals the mass in grams from that periodic table. So let's take a look at oxygen because oxygen is something that you may often have to calculate. All right, so this would be a great time to pause the video, use your periodic table, your calculator, and see if you can figure out the mass of this oxygen gas. Awesome. So hopefully you figured this out. And you got 0.609 grams of oxygen gas. Again, that would be rounded to 2 significant figures. So what did I do here, just in case you didn't get the 0.609? Otherwise, you can fast forward along. So your liters, I took my liters. I took that known ratio, that 22.4 liters of any gas is a mole. My liters cancel out. Then my moles cancel out or diagonally drop. And then I put this over 32 grams because it's O2, not just oxygen. So once I multiplied across the top, I got that. On the bottom, I had 22.4, divided them, and then rounded to 3 significant figures. All right, let's try another one, another medical situation. I believe I have coming up soon here. Hold on. Sorry, I'd done all the canceling out for you. All right, here we go. Silver nitrate. Great time to pause this video and see what you can get. All right, so silver nitrate wound strict. So hopefully you started with your formula, and that's a problem where I see on this Unit 2 test is people often not writing the correct formula, which then gives you the incorrect formula mass or molar mass. And so if I already know moles of AgNO3, then just have to multiply by my molar mass here to get the grams of AgNO3. Notice my moles are going to cancel out, and I rounded to 2 significant figures because those are my 2 significant figures in this problem, the 13. All right, you can also do mole to mole conversions using the periodic table. So here's a quick question for you. See what you can do. So hopefully you started with what you were given and then looked at that equation and came up with 3 moles of O2 equals 2 moles of Al2O3. And so that gives you 5.01 moles of O2. And then, of course, I could easily now figure out the mass. I could use the molar mass of O2, which is 32, to figure out how many grams of oxygen. I could figure out the volume of oxygen with 22.4 liters is equal to a mole. I could figure out the number of particles of oxygen using Avogadro's number, 6.02 times 10 to the 23rd. Particles is a mole. And so that is super important to be able to do that. All right. And so once again, just reminding you of those moles and that you can use that equation and write those conversion factors. You can also flip those conversion factors. So it doesn't matter how you write them. It depends what you're looking for, because what you're looking for needs to be on the top and what you're canceling out should be on the bottom. All right. So here's another one. Often you have mass to mass stoichiometry problems like you had in this stoichiometry lab. All right. And so nitrous oxide. So go ahead, take a moment, read the problem, see what you can come up with, and then I'll show you the answer. All right. And so let me take a look and see what we've come up with. I think I go to a new screen here. I did. All right. So again, always starting with what you're given. And so making sure I'm writing that formula right. N2O, yes, dinitrogen monoxide. There's our molar mass of dinitrogen monoxide. Looking at our equation, 1 mole equals 1 mole. So we got that nice and even. So even though we all know that, make sure that as you're solving these problems, you're putting this mole ratio in there. That is very important to do each time. And then your molar mass. And then so I'm going to just multiply straight across the top, divide by the bottom. Notice what's canceling out here. All right. And so my grams also canceled. There's that grams canceling. So I'm getting top and bottom. And so there's my answer. So I'm going to have to round that to 3 significant figures. So that's how many grams of ammonium nitrate we would need for that nitrous oxide. And some dentists have to do that reaction. They're using the laughing gas in their offices. Now, what is that number called? Yes, that is our theoretical yield. I'm sorry, it's off my screen a little bit. I apologize for that. Right? But if I'm working in the office and I make 45.1 grams, what would be my percent yield? Again, a great time to pause the video. So hopefully you remembered that actual divided by theoretical times 100, and you should come up with 74.8, which is a pretty good theoretical yield. Like I said, from an industrial standpoint, we look for about 80%. All right, here is another one. Have you ever heard that old myth that the camel's humps are full of water? Well, that's not true. It's really fat in their humps, and you can extract water from that, and the camels extract water from that. All right, so there's our chemical equation. It is balanced because that would be a bear to balance that. So if you had 1.24 grams of that camel fat, how much water would you make in grams? So great time to pause the video, see what you can do. All right. So I worked this problem out I worked everything out. And so there it is. So first I took my molar mass of the camel's fat, which was pretty big, obviously, because we got a lot of elements there. Then I used my mole ratio from my balanced equation. 110 moles of water is equivalent to 2 moles of fat. Then I did my molar mass of water and got my answer. Now, could I have stopped right here? Could I have just converted the grams to moles and gotten an answer? Yes. And then gone to the next step. Use the mole ratio? Absolutely. You could definitely do it that way as well. And so I came up with, there we go, 1.38 grams of water you would get. So just a little bit more water out of that fat than the fat itself. I hope this helps you as you're working and preparing for your Unit 2 test.